Welcome to InnoBuzz Java Video Tutorial Part 7. This chapter covers knowledge on packages and interfaces. Interfaces are some kind of special classes that assure us a very high level of abstraction. Packages are the biggest units in Java language that can contain and collect interfaces and classes and all the program parts that we were talking about previously in the chapters. Let's see an overview. First, we will talk about the basic knowledges on packages. Then we will see how to create and name a package. We will talk about accessing the package members from program code. Then we will start to talk about the interfaces, how to create and implement them, how to use them in our programs. We will see how we can extend the interfaces. We will discuss then, in general, why and when to use these interfaces. Why are they important? And at the end of the chapter, we will talk about a programming paradigm that is related to interfaces, the programming by contract. As we increase our knowledge on programming in Java, we will write bigger and more complex program parts. After a while, we will need to use some structure in our codes to set it in some kind of structural way. This is provided by the packages. Packages can collect every program part that we have learned so far. What are packages? These are some kind of namespaces that organize a set of related classes and interfaces and everything. So we call these members. This can be stored in a structure in a way that is closer to a library structure or something. In fact, the packages are in libraries. Now, what can we have in a package? As I told, we can have the classes, we can have the interfaces that we are going to talk later in this chapter, enumerations, annotation types. So mostly everything, basically everything. The Java packages are usually stored in jar files, directory structures in our computers, and when we create any class, it has to be in a package in some way. The Java generates a package for it if we don't do. It's an empty package, an unnamed package. Java allows us to use a huge, really very big amount of packages that are already prepared for using by programmers that obtain us lots of very useful codes in a structural system that is really very important to know some parts of it. And we can check this at the Java platform SE7, for example, at this http docs.oracle.com/java/7 docs.api-index.html. We will browse a little bit in this page to look around what we have there. How to create a package and what are the rules and naming conventions that are commonly used. Well, a package can be created in a very easy way. We have to use the keyword package, and we have to give the name, the package name, and the semicolon at the end. This statement must be the first line of our Java file. So this has to be before any class declaration or anything. What can be the package name? There are no rules, no strict rules for it. The important thing is that we have to use names that are different from other names, other package names. There are no strict rules about it, but there are some conventions that we should take care about because they can make us easier to make the programs, and we can avoid some problems by taking these advices. The package name, we always have to write all lowercase, all the letters, because the class started with big ones, and variables also had some uppercase letters. So this way we can know that this is a package name. For the companies, they usually use some reverse domain names. It can be important because in a company there are many segments of programming, and also sometimes regions, and when they put together everything, there have to be some rules to create the packages and to reach everything, to organize it together. The Java packages that are available for us always start with the Java or JavaX. So they start from this library structure. How can we access members of the packages? While we are writing codes, we have to use members of the packages. Well, if we are using members from our own package, we don't have to write any prefix because we can reach everything from our package, which is not private. And also there is a Java package that is called java.lang that we can always reach without any extra lines or anything, any naming. But all the other packages we have to access some way, and there are some rules for it. So we can access a package with a fully qualified name. Now this way, for example, when we create an object or instantiate an object that has a class that belongs to an outer package, we have to give the whole name of it, like the package and the sub packages, that the member packages that in there, and the whole structure, and at the end we have to name the member class, for example. This can be good when we only use it a few times in our code. It's no problem that it's a little bit longer, and we don't want to write too many times the whole qualified name. Then we should import this package member. This way we put an import statement at the beginning of the file after the package declaration. So the package declaration is the first line, and right after it come the import statements, which look like this: import package name dot and member. Of course, if we have a package structure that is more complex, then we use all the package names. After this, we can reach the member by only the name. For example, if this is a class, then we can create objects from it, just like as if this was in our class, our package. But what happens if we want to use many more things from the same package? Then it is better to import the whole package. This is also an import statement, so in the same place. but we use it import, the package name, and dot and the star. So this way all the members from this package will be imported and we can use them. As I have promised, we are going to spend some time on looking around here at the website of Oracle, uh, watching how this platform looks like, the Java platform, Standard Edition 7, the API specification. Programmers during their work often come here to this site to look for some specifications on classes or anything. As we can see, we have all the packages that are available in the Java for us that we can use in our programs if we import them. There are a lot. So, and in these packages there are also some very useful classes that we can see here, many classes, and they all contain very useful codes. So for example, this is the file class. So if we will create files in a later chapter, we will use this, for example, for a file. We have also the packages here. We can see this is the applet package, provides the classes necessary to create an applet and things like that. The AVT we are going to use for the graphic, so the graphical user interfaces, and there are many sub packages of that. Input output, Java.io. This is for system input and output. The Java lang. Yeah, these are the most fundamental things for the Java programming. We don't have to import this, as I told. Java math for mathematic things. Knows everything. What we need. The NAT is for networking applications. So lots of things. The SQL, which we will use for the database things. Okay, so lots of things. For example, I'm just going inside one of them, the Java util. This contains collections, framework legacy collection classes, and so on and so on and so on. We go into it just to see what it is, what's there. Yes, there is short description here about them, and we see what interfaces are here. There are lots of interfaces for enumerations and collections and things like this. There is the classes, lots of classes. Some array things. This is the date class, date representation. It's also important. There are some enums and exceptions. We are going to talk about them later. What I wanted to show is one of my favorite things is the stack. Yes, this is a class stack. So we can see the structure, the hierarchy of the objects here until our stack, for example, now. So it's in the Java util. package, and the parent classes are here. So it's Java util stack, the parent of it is Java util vector, Java util abstract list, abstract collection, and the parent at the top is the object. As everything has this, everything comes from the object, and these interfaces are implemented here in this class. We are going to talk about the interfaces a little bit later. Yes, and the parent is the vector. Yeah, this is a LIFO stack of objects. As we were talking about the arrays, the most important thing was that an array has a type and the size is fixed. Now the vector is a little bit close to this, but the size of it is dynamic. So we can put in things and take out them, and the stack. I use the stack many times, and we can reach the elements we can put in and take it out. So it's a very dynamic and very good usage, for example. Now that was about the stack. We have also talked about the strings. Well, I'm trying to find the string here. String. This is the class string. It comes directly from the object. These are the interfaces. The string class represents character strings, all string literals in Java programs. Yes. We can create it just like this. It is equivalent to a character array. But it is important that we won't be able to really reach and change the strings. So the strings are a little bit hard to modify and work with them sometimes. So sometimes we will use string buffers, which are here, to cope with the strings, and we will typecast into each other them. Now that is about the Java packages and Oracle.com. It is worth the time to look around here and just browse these pages and look around in the classes that we have used or already, or what you can use. Or sometimes the important thing is that we don't have to invent the wheel, as we say. So we don't have to write everything in our programs. For example, if we want a stack or something, it is already written. So we have to use them as some kind of bricks or something when we are building our program, as we imagine building it as a house or something. We have to use the complex classes that are here and available, and it's good to know what's in here. Let's see now how the packages work in practice. Well, in fact, we have already seen the packages here in the NetBeans, because when we used the previous projects here, I have the same, the girl, the guy, and the person now. So when we use them, we already used the package. And this was the first line, as it has to be. It's called test project, and it's all with small letters, so no capital letters. So this is the way to do it. All the files have this in the first line, so they belong to the same same package. So this is this way we can see that they can contain the classes and everything that we have already done. This is abstract class, so the methods and the fields and everything are inside them. What I want to do now is to create another one here. I have this project here in the NetBeans. It's a test project. I want to add something. I say new Java package. And the package name, well, just call it package or second package. I use small letters. And there is another package created, as we can see it's here. Nothing inside. The second package is here, and I can add a Java class here. Well, let's say no matter what it is. Test class or anything. Starting with capital letter. Test class 2. No matter. Well, it's a test class 2. It's okay. It's created, but and it belongs to the second package. Second package. I want to add something like this, something like something inside. Just avoid main. Well, we already have an error. What's the problem? The problem is that we cannot reach this person because the person is in the other package. So if I want to use it, I have to use the name of the package. So this is going to be a fully qualified name. I say that test project, which is the other package, dot, and we see now it's here. This is a person. I call it guy. It's okay, but the new guy is not working also, the instantiating. So I have to say test project dot guy. That's it. And this way I can do it. It's okay. Now I can use it just like there. Guy dot, and it has got all the things that we need. Okay. Just for showing, we can say that, for example, importing. So I can import. I can put an import statement here. I say that I import test project dot person. And this means that from now on, this member of this project is imported, so I don't have to use this test project dot person. I can write just simply person from now on. It's okay. But still, with the guy, I cannot do this because the guy still not seen from here. We still cannot see the guy. What I can do is write also that import test project dot guy. Well, it's okay, but if we have many different things here, and of course a bigger package, then it is not very uh, easy to write all the lines, all the members that I want to have this and this. I just say test project dot star. So this way we have everything from this project, every element of it. And this is the guy working as well. Okay, let's play a little bit with the accessing of members. I save it this way, and I go to the other one. I go to person Java. We see that we have private things here. The private things cannot be reached from anywhere outside the class. So I cannot reach the string name from test project as we have seen. That's why we created these public methods. I say public gender, get gender, and set gender, and things like that. But the publics can be reached from anywhere. So I can say that we have here the other package. I say guy dot and get gender. That's it. It's I can get it. Well, we don't even see the gender as well, because it's inside the person. So we have to say that person dot gender. Person dot gender. Yeah. Okay. So I can do tricks like this. But what happens if I change it just to show the access mechanism in during our work? If I set these to, for example, to protected, just these two, just these two. These are protected from now on. I save it. What will happen? Well, here there's no error. We can reach everything. This is the same. But here we get an error. I cannot use the get gender anymore. So if I say guy dot, I have the get age and all the other things, but the get gender I don't get anymore because it's protected. Now that was about packages in the first site. What I wanted to show as well, as we have talked about some packages, for example, from the Java libraries, then it's going to be good, for example, to, yes, let's do it with the stack. I write an import here, import Java dot, and we have got all the things here, all the packages that start with the Java, and it's in util, Java util dot stack. That's it. Yes, and we can see the things about it in this description, the most important things. I import Java util.stack, and this way I say that stack our stack is a new stack. That's it. I don't have to say how big it is. How big it is. And then when we create these guys, I can just say that our stack dot push, and as you can see there can go any object, so it can take any object, and I just push the guys there. I don't even need this thing. I say new guy, I push it in the stack. I copy this, and all the guys are pushed into the stack. And we don't have this anymore. Okay. So we have our stack. But we cannot use this anymore for this. Okay, I clear it. But we have some guys in a stack now. What we should do now is to create a different type of, different kind of get average mass index to be able to cope with stacks as well. I copy it and I try to make it quickly. Well, if we want to do this, we should also use the stack importing there. It's the easiest thing to do. After the package declaration, the package yeah, we have this and we just say that it's a stack. So we get the stack here. And person count mass together. And what we do is we go through the stack. Yeah, because the stack contains the person. So you know it's yes, it's this just same thing. I do this for one level. So what's the big problem? Oh, yes. So I use only one for cycle, so I should have copied the other version. So we go through the persons from the stack. Yes. And this is an object inside. I can see that object first, and there's no problem. But this way, I have to say this is a person, so I have to use a typecast on it. Oh, yeah. So this is how it can be done. I use the stack, I put things in it, and when I get them out, they are objects, but I know that in this stack I will put persons, so I use the typecast. There is also a possibility to specify what element types go into the stack, but I'm going to show it later. Now this was the usage of some Java classes, that Java packages that these can be very useful. They have implemented lots of very useful things, so it's worth the time to look over a little bit, look around into the Java site. We are going to see the interfaces now. What do we call interface? Interfaces are reference types that define a protocol of communication between objects. They only contain constants and method declarations with signatures but without implementations. And all the classes that implement these interfaces have to write the program codes, have to implement these methods that are in the interfaces. Then these are abstract methods. We can create an interface with the interface keyword, public interface, interface name, and it can extend also other interfaces. We will see that in a later slide, how to do it. And inside the brackets, we have constants with the type name and constant name, and we give the value. We don't even have to add modifiers to these because they are implicitly public, static, and final. So they cannot, the value of them cannot be changed in any way. That's why we call them constants. And there are also the method signatures that I've been talking about. There can be voids or some kind of type. We have the method names here and the parameter list, so signatures, and the end of the line is a semicolon. So as we've told, no body, no implementation for them. How do we implement these interfaces? When we create a class, we can specify that our class implements this interface. So implements keyword and interface name. But this way, we declare that we will write an implementation for all the methods, all the abstract methods that are inside the corresponding interface. We can use more than one interface name after the implements, so we can implement more than one interface in a class. So we have a method, public void method from an interface with the parameters which give the same signature as it was in the interface, and we write some program code inside. So this is the implementation. And don't forget that we have to do all the methods and we have to use the same signatures. How to use the interfaces? When we create program codes, we can create variables which have the type of an interface. So interface name variable. And this way the variable's type will be the interface. But as I've told, we cannot instantiate interfaces. So when we want to instantiate this variable, then we, after the new keyword, we can call the constructor of a class that implements our interface. That is an implementing class, and of course the parameters that are needed for the constructor. So this is the way we can do it. And if we want to call a method with this variable, for example, there is a method somewhere that that we call with this variable that was created this way. This has to look like this. So this is a method, and the parameter of it is that has a type of the interface. So the interface name and param. This way we can pass any variable that was declared by the interface name, and no matter what class we instantiated it. So there can be many classes, and all the classes that implement this interface are going to be good for instantiating our variable. So we can pass it to the method. And inside the method, for example, we can use the param dot and all the implemented methods. So all the methods that were in the interface, all the abstract methods from there that were implemented in every class. So that is why we have to do it all, because then we can be sure that they will be implemented, and we can call them from anywhere. And we can call the implemented method from here. How to extend interfaces? Well, as I told, the interfaces can extend each other. Why is it important? We have an interface, for example, here. I call it old interface. It has got two methods here. The first is a void, the second is has some kind of return type. And this is how we created this interface lately. And of course, there are some classes who implement this, but later on we think that we want to add one more method signature. So of course these are only signatures, so abstract methods. But what happens if I add one more here, one more line here? Then all the classes that implemented this interface will get an error, because they can only implement the interface if they implement all the methods in there. And if I change it behind the scenes, then they will get an error, because they don't implement the new method. So if we have a big company, or if our interface is used all around the world, maybe then it's not a good solution. What can we do? We extend our old interface and create a new interface that has got inside a new method, a third method. So this way our new interface will have all the abstract methods of the old interface and one more new. And from now on, if someone wants to create a class that implements our new interface and knows that it has some extra methods, and it extends the old, then they can use the new as well. But the old also works. Why and when to use these interfaces? Well, we have talked a lot about them, but let's make some conclusions about the interfaces. Why are they so useful to us? Well, first of all, they provide a possibility to create multiple inheritance in Java language. This is important. So as I've told, we can implement more than one interface, and also the interfaces can extend each other, and more than one they can extend. So normally in Java language, there is only single inheritance, so we can extend only one class, and this way it provides us some kind of multiple inheritance through the interfaces. They define what to do and what has to be done and not how. So this is like we have the abstract methods, and this way we tell that what has to be done. But the implementation, how they implement it in the classes, are up to the programmer who implements it. And this way they provide a communication surface. So we can know that if anywhere in our program we use a variable which belongs to an interface, which gets a type of interface, we can know that how it will behave, what kind of methods it has, and so on and so on. So we can be sure that what we get. And as I told, we can use it for variables as a type, and we can pass it to methods, for example, as I've shown. So this is very useful. And also there is something called programming by contract, and that I'm going to talk about in the next slide. So programming by contract, what is it indeed? Well, it's something that is called a paradigm, which was introduced by Bertrand Meyer, who created the AFL programming language. This is an important thing in programming, that this talks about a negotiation between the creators of software and the users of it. We have a precondition how to call a method, for example. So there are some rules that we have to follow to be able to call a method. There are the ways that we have to do it. There's a post condition. Is what we have after the method. What has the method to do? What is the outcome? This is the post condition. And we can have an invariant which provides us a checking. It's some kind of condition that has to be true before and after the method has run. So this way we can guarantee that the method has done what we wanted and it didn't mess up the things, our variables, and so on and so on. So this is a contract between the software developer and the user. Well, let me tell an example. Let's say that in the United States there is a franchise system of fast food restaurants. I have it. I have all the rights for it, and some people come from Europe and maybe from India too, that they want to use the same franchise restaurant system. Then I say that, okay, you can use this franchise, you can use the name of my restaurants, but you have to follow some rules. You have to be able to fulfill my preconditions or something, that, for example, your restaurant will look like, as I tell, the color of the building and the design, and the tables will look the same, and the clothes that the waiters wear will be the formal clothes, and also the food, that the menu will be the same or very close, and so on and so on. And I tell what kind of music you can play in your restaurant, and I tell what the food has to be like. But it's not the same in every country, of course. So, and it's about implementation. So how they do it in Europe or how they do it in India. Of course, they have to use the same clothes, for example, for the waiters, but they can produce those clothes in the factories in Europe, for example. And I say that if you use my franchise, you have to give quality meat to people. So I say you have to use, for example, for the hamburgers, quality cow meat. But I won't export cows from the United States to Europe or to India. You have to use your own cows, of course. So it's the own way. So there are the European cows and the Indian cows that are going to go into the hamburger. But maybe maybe this wasn't the best idea to talk about the cows, but as they are saint in India. But we can do the same thing with the chickens, so or anything. This is the contract thing. It is also related to the interfaces in Java language. It's the same thing. So I say that okay, you can use this interface, you can use this franchise, but you have to do all the things. So you have to fulfill the terms and conditions that I expect. So this is something about the programming by contract. We are back here in our test project, the person, the guys and the girls, and we are going to see the interfaces in practice now. So, there's only one thing that in the previous demo I forgot to do, is that we created this get average mass index for stacks, but I didn't try it out, and I just want to do that before that. So I say that system dot out dot print line. Okay, I just write a short thing here, and I say that person dot get average mass index, and you can see this is the stack version also here, and our stack. That's it. Average, and this is the average for the guys. Okay. Now to talk about the interfaces. First, create some interface here. I want to create an interface in the test project. I come here, I say right click, new, and Java interface. What to call it? Let's call it person interface. Person interface. Okay, finish. And we already got the interface here. It's in the same project and it's an interface. Well, what can we add here? I want to create an interface for the persons, but normally the interface should be created first, but now I cheat a little bit because we already have a class here with lots of things inside, and for example, I put this one there. Yeah, so there should be this, The static ones I cannot put there, but the other things can be put there. Well, all these things, all these methods. We put into the interface, but of course there is an error because they still have the bodies. I just cut these out. Set gender, add gender. Yeah, it cannot be protected inside an interface. Public. Yeah, he doesn't know the gender as well. So where is this gender in the person? This is not good this way. Well, anyway, I don't need this gender thing, so I just want to show the basic things. So I add a semicolon at the end. And they become abstract this way without any implementation. Okay. That's it. So this is an interface which has these methods, these abstract methods, that if we want a class that will implement this interface, the class has to implement all these methods. So these are a collection of possibilities that they have to use. So I save it, and if I go to person Java, which is a class, an abstract class, and as I told, abstract classes can also implement interfaces. I write here implements person interface, and if I type it right, then it's gonna work. So implements person interface, because all the the highlighted methods are there. It's working. I save it, and everything is working the same way as it used to be. So it makes no difference. But what I can do here is say that from now on, the person array here can be exchanged to person interface. So I can use this interface as a type, person interface, and also this. So this is a type name from now on. So I say that there is an array or a multiple dimension array from this person interface type. And as you can see, I have this person interface type of array, and I can put the girl in. The girl is here. The girl extends the person, so it's the child class f person, which implements person interface. So this is the abstraction. This is the hierarchy system in Java, and I have to use it here as well. Yes, and here. So yes, but this is yeah, this won't work with the this won't work with this parameter. We don't cut it out, but these will work. So I can use this person interface type from now on, and of course I save it and I try it out, and it works all right. So it's very good this way. And of course, as I said, this this allows us a possibility to pass other classes as well. Every class that has this, that implements the person from now on. So if I create another Java here that is going to have a different class name, and it can be different in many ways, I can use it just like this. Well, I can use something like, okay, I create a new Java, I call it human or something, human Java. In fact, I will copy most of the things. I will copy everything and just make changes because it is really long. This is the easiest way. What I will do is to say that it is I don't need this to be abstract, and I call it human. 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 What's the problem? Yes. Okay. The only problem is this, that it doesn't override it. So yeah. So it says the human class, it's not abstract because I deleted the abstract keyword, and does not override this abstract method. Yeah. So of course, if it's not abstract, then I have to do something here. Just return 0 or something. Yeah. And it's not abstract anymore. So there are no more arrows. So I have this human Java, and we can make, of course, we can make other things. we can change anything here in these. Get body mass index. I can do something else here. I can say that +2 or anything. So I can change them. I can give different implementation to all these methods that are inside, and what I have to do is only I can, for example, delete these static things. This is another Java, this is the human. What has to be the same is that we have to implement these things. And if we do that, then we can call it a person interface. And from now on, I can put humans or anything. Yeah, I can. Well, the humans will have to take the gender and everything, but I can say it's a human. It's a human. It's a new human, and well, I think we have the enumeration here as well. Oh, it's okay, no problem. I'm not gonna change it. I say human dot gender dot female. That's it. I already added a human here, and it's also working with the person interface. I can change all these to human, for example, and do things like that. And I can be sure that all these classes that implement the interface will work because they all have the same methods. So they have the get name and everything, get the ID body weight, because it's implemented there. It has to be implemented there. But the implementation can be different, as I told. Now that's about interfaces for now.